Yeah, Bismillahirrahmanirrahim. Assalamualaikum. Very good day to you all. Okay, in this video, I'm going to talk about chapter 2.3, which is strength and core work for mostly mechanical engineering design. Okay, this is the topic that I'm going to talk about, topic 2.3, strength and core work, and this is the figure that we're going to refer in this topic. Okay, so introduction to core work. Okay, core work is deformation, plastic deformation before recrystallization temperature. Okay, involve shaping material without heating them above the recrystallization temperature, leading to an increase in strength and reduction in the ductility. Usually, we are using force lah. You imagine you have a pressing machine. That pressing machine, you put the material below it. It will be pressed according to its mold. Okay. During the process, it we reshape the all the atoms. We become more strength lah. Okay, and reduction and ductility, meaning that the material become quite brittle one. Okay. Another way to do the reshaping is using temperature. We burn it into the temperature just below the melting point. Okay, so that we can easily mold it. Okay. But that is a different topic lah. Now going to talk about the cold working, which is shaping the material without making it melting, okay, without using temperature. So there is a thing called strain hardening through deformation. As the material is deformed, its strength increase, it become more resistant to further changes in shape and but with in reduced ductility. Okay, common industrial process such as bending, drawing, and cold rolling are still a typical example where cold work is applied to increase strength. Okay, things that you can you may use it. I'm sure you as engineering student, you have used it throughout your life. It is the hammer. I'm sure everyone engineering student or non-engineering student have used a hammer throughout your life to hammer the nail, hammer everything and everything. Okay, let's say I'm going to talk about hammer in relation to the strain hardening mechanism. What is the relation between a hammer, okay, with strain hardening? Okay, suppose you take the hammer, you just buy it from the shop, never have been used before. Okay, and then you do the tensile strength on the metal of the hammer. You find it is certain value. Okay, and then you use it again and again and again. After so many times you use, you test the strength of the hammer. You will find it become more increased strength. It become more increased strength because the atoms inside it uh, restructured because it become more strain hardening. Okay, this is more strain hardening. This it is occurs when the material is deformed is beyond its yield strength. Okay, yield strength you can find it in my previous video what I explained about yield strength. Okay, it leads to increased resistance against further deformation. Higher yield point on reloading after strain hardening, the material shows higher yield point during subsequent leading cycle, improving strength but reduced ductility. So, what is the relation with reduced ductility with hammer? Suppose that certain hammer that you have used again and again, you use it for a long, long time, again and again. Suddenly, it become broke. Okay, it become a fracture. Why that hammer become fracture? It is because it it has no ductility anymore, that it become brittle, and it is broke. That's the way it is. Okay, everything in the world, it will become high speed and then it become fracture. It is the way it is. Okay, there are strain components, elastic and plastic. The total strain is composed of elastic and plastic strain component. With cold working materials become more brittle and prone to fracture. Okay, so quantifying the cold work reduction on in cross section area. Cold work is quantified by measuring reduction in the material cross section area during deformation, impacting its strength and ductility. Cold work formula. Degree of cold work is calculated using the reduction of materials area before and after deformation, impacting yield strength. Improve fatigue strength. Cold work strengthens the material against cyclic stress by reducing local hardening and enhancing performance in fatigue prone application. Okay. And practical example is this lah, AISI 1018 steel. Cold work subject to 50% cold work exhibit significant increase in yield and ultimate strength. Property enhancement yield strength increase from 32 kpsi to 57 kpsi. Ultimate strength rise to 39.5 kpsi to 58.2 kpsi, making material suitable for high stress application. Okay, cold work steel is widely used and automotive component due to enhanced ability to resist repetitive stress and cyclic loading. Okay, that's all for the video right now. Inshallah, we meet in the again in the next video. Thank you very much.